Hey boys and girls, this is Miss Gross, and today we are talking about area and perimeter. Now, our I can statement for today, read it to yourself as I read it out loud. I can statement. We say, I can find the area of a shaded region. So what we're going to be doing today is finding the area of a region that is shaded in where you cannot see the squares. But first, let's do a quick review of how to find the area of a region that you can see inside of the region. So it says find the area of the region below. And we know the area is what is inside of an object. It's all of the space inside of an object. And we can count it by going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, and 49. Now, we know that it's really important that when you count the area to write the numbers inside each square so that you don't get mixed up. But because there's a lot of squares here and a lot of spaces that we need to count, we know that it can be easy to miss a number or to accidentally skip a number or to go back a number, so you need to write down your numbers in each square. So we found out that the area of this rectangle or this square is the area equals 49 square centimeters. Or you could say centimeters square, it's up to you, because each of these is a square centimeter, meaning that each side is made up from a centimeter. So we have 1, 2, 3, 4 centimeters, that makes a square, and we have 49 of the square centimeters. So our area was 49. Now, I have right here the same exact square that we saw on the last slide. I'll go back again, right there, right there. But all I did was I covered up the inside of the region, inside of the shape, so that you could not see it. Now, we need to still find the area of the region below, but we're finding the area of the shaded region, what's shaded, so what is red. Now, I'm going to put a 49 up here, because remember from counting the last one that there are 49 squares on the inside. So we need to use what we know about this square and about grid paper and about the strategies we've done to practice finding area in order to find the area of a shaded region. Now, when I was talking to some of my friends in class today, I said, okay, friends, let's talk about some strategies. What could you do? And a lot of my friends said this. You could draw lines through the whole thing, your lines down, your lines across, and then you could see how many there are there, and you could count them up. And that is a possibility, but I know that sometimes when I count, I can get off and maybe make them a little bit crooked, and then my squares would not be even. So when I have big shapes like this, that's not always the best option. So I said, okay, friends, well, what else do you know about this square? And they said, well, it has 4 sides, it has 4 angles, all of the sides are equal. And then one of my friends said, well, Miss Gross, I know that you can find the length and the height of a square. And I said, okay, well, how can you find the length and the height of this square? And this is what my friends did. Watch carefully. They said that there's 1, 2, 3, 4, 5, 6, 7 boxes or 7 square centimeters on this side. So we wrote a 7 over here. And he said on the bottom we have 1, 2, 3, 4, 5, 6, 7 over here. So I said, okay, friend, that sounds good, but I don't know what to do with these numbers now. Now we have 7 and 7. We have 7 down and 7 cross. And I said, well, friend, what does 7 down and 7 across remind you of? And they sat there for a minute, and I kept saying it. I said, 7 down, 7 across. 7 down, 7 across. And they said, well, Miss Gross, that reminds me of the area model. And I said, that's very interesting. Let's draw an area model. If we have 7 down and 7 across. 1, 2, 3, 4, 5, 6, 7 down, and 1, 2, 3, 4, 5, 6, 7 across. And then I said, with this area model, what would we use this for? And they said, well, we would multiply 7 down times 7 across to see how many there are in all. And I said, well, what is area? And they said area is how many spaces you have on the inside, how many spaces in all around the inside. And then we came to this conclusion. If you did the same exact thing inside your square, you had 1, 2, 3, 4, 5, 6, 7 down, and 1, 2, 3, 4, 5, 6, 7 across, we decided that you could multiply 7 times 7 just like you would with an area model to see how many spaces there are on the inside. Or when you do multiplication, you would see how many x's there were on the inside. And when we did 7 times 7, we got 49. Now, that would mean that we had 7 down and 7 across each time. So there would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. So there's 7 down and 1, 2, 3, 4, 5, 6, 7 across each time. And when you multiplied that 7 times 7, you got the area as 47 square centimeters, which we knew was the exact same thing that we found when we actually counted the inside. So we decided that when you're trying to find the area of a shaded region, you can multiply your spaces down by your spaces across to see what there would be in all. So let's practice that. Watch closely. So I have the same exact square here and there, because if you don't believe me about this trick, you can always check me on this side to make sure I'm correct. Now, using the same strategy, we're going to do how many down times how many across equals your area. Okay? Now, in math, we would say your length times your height equals the area. But for right now, we'll just say down times across. So I have 1, 2, 3, 4 down. If you don't want to write it that way, you could also write it like this. Oops. You could write 1, 2, 3, 4 down, and 1, 2, oops, sorry. Now, we remember with area, we have to count this one twice. So we had 1, 2, 3, 4 down, and 1, 2, 3, 4 across. And if we take those, and if we do 4 times 4, that equals 16. Let's see if that works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we see 4 down times 4 across equals 16 square centimeters for our area. Let's do another one. So this one's a little bit bigger. I'm going to change my color just to change it up a little bit. Let's do orange. Now, we know that down times across, or length times height, equals the area. So let's see how many down we have really quick. We'll do 1, 2, 3, 4, 5 down times 1, 2, 3, 4, 5 across. 5 times 5 equals 25, because we've been studying our facts. Now let's test that. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25. So again, our method works. We're going to try just a couple more and then we're going to move on. So we have a rectangle now. So it's not going to be the same down and same across, but we're going to use the same exact strategy. So let's try it. Now we're going to do the down times across equals area. Let's count how many down we have. We have, starting at the corner, 1, 2, 3, 4 blocks down. And we have 1, 2, 3, 4, 5, 6, 7 across. And we know that 4 times 7 equals 28. So there should be 28 in all. Good. One more. Let's try this one. 1, 2, 3, 4, 5 times 1, 2, 3, 4. 5 times 4 equals 20. And that is how you find the area of a shaded region where you cannot see the squares on the inside.